Hello everybody. This is the Samurai Jack question answer. Can somebody help me on that Humpty Dumpty worksheet? There's a question about Samurai Jack and he throws his ninja doll up in the air. Is he standing on something or is he just on the ground? He's on the ground. So Samurai Jack is here. He's a ninja, so. A man bun? Like that? And he throws his ninja doll up. And with an initial velocity of 30 meters per second. So he's got his little... He throws his ninja doll up and comes down, okay? And the VI equals 30 meters per second. Now, I've had a lot of discussions with people about up and down and positive and negative and what that means. The truth is, in physics, positive and negative are arbitrary. They are just directions. Any two opposite directions can be positive and negative, or positive and negative. It's up to you which one they are. Usually people take up as positive, but it doesn't matter. You could choose down to be positive and up to be negative. It would work out to exactly the same answer. I encourage you to try this. We're going to say that up is positive and down is negative. So we'll say the initial velocity is positive. Now the question C, the most interesting one in this problem, is at what two times is the doll a certain height? Is it 25? 25 meters. How can there be two different times when the doll is 25 meters? Adam's going like this. Ashley?
When you throw it up, it'll hit that 25 increment mark, and then when it falls back down, it'll hit the 25 increment mark.
Excellent. So if this is 25 meters, that's the displacement, right? That's going to happen at two different times, on the way up and on the way down. Is the displacement different on the way up than it is on the way down? Like is one positive and one negative or something like that? Or is it the same displacement at both times? The answer is that it's the same. If I throw something up, on the way up, it's maybe a meter above my hand. On the way down, it's still 1 meter above my hand. The displacement is still positive. What would a negative displacement look like? It would have to be down here, below my hand, right? So for him to be negative 25, he'd have to be down here somewhere. So both times the displacement is positive 25. So we have a VI equals positive 30. Do we know the VF? No. The velocity at the top is 0. Do we know that 25 meters is the top? No, it's not the top. So we can't say that VF is 0. If we wanted to know how high the doll went at its highest point, then we would make VF 0 and we would solve for D. But we don't know what the velocity is here. So VF is out. What else do we know? We know the acceleration. What's our acceleration? And I'm going to say negative 9.8 because if up is positive, acceleration is downward, right? So this has to be negative. And we know one other thing. What else do we know? know the displacement. Displacement is going to be positive 25 meters. And what are we looking for? We're looking for time. So you can look at all these four, or you can say, well, there's no VF. So which formula has no VF? This displacement run, right? So we can say D equals V T plus half A T squared. And we're gonna have to solve for T. That's gonna be tricky business, right? We can do this in one of two ways. You can use the quadratic formula, and you can solve for time, which will give you two different numbers, remember, right? And those two different numbers will be the two different times. If you know how to do the quadratic, you put this first and this second and this last, so you have to subtract the d over here and equal to 0. And you can put it in your calculator, or you can write out the quadratic, and you can do it that way. Or, for those of you who don't know this, we say, well, I don't like this because VI is not 0. And solving for T is going to be tricky. So let's do it a different way. Let's do it in steps. Step 1 is find VF. How can we find VF? We're going to have, we can do, can we just,
VF equals VI.
we're going to have to do this way, right?
Oh, yeah. Oh, no, because
Because we don't know the time. So if my VI is 25, my acceleration is negative 9.8, and my displacement is 25. We're going to get a VF. Now, what? Oh, it's 30, thank you. 25 is displacement. Thank you, Yasmin. This is 30. That makes it easier, actually. So this is going to be, this is going to find VF squared for us, right? So what do we need to do to find VF? Good, I got to get rid of that square, right? This is where we're going to get our 2 times from. Because we're going to have 2 final velocities, right? So if I square root all of this, that's going to be about 900, right? 900 plus 20 times 25, that's like 500. So 500, 900 is about 1400 square root. What's the square root of 1400? I don't know. My brain's not working very well. Connor.
It's actually 400 because it's minus.
Oh yeah, good for you. Good for you. This is negative, right?
Yeah.
And our displacement, you got to check these signs because there's always a kind of weird one, right? So this is negative, this is positive, and the 30 is positive. It's upwards. So yeah, you're right. So it's 500 minus 400, so 100, so about 10. Is that right?
It was 900 minus 500.
Oh. Okay, yeah. Sorry, 900 minus 400. 500, which makes 400, which makes it easy. So this is going to be the square root of 400, which is about 20, isn't it?
Yeah.
No, it's not.
Yeah.
Is it? Oh yeah, okay. So VF equals, now, here's the thing that you have to remember. You can do all this part on your calculator, you don't have to do this in your head. We get 20, but that's not quite right, is it? Good, Sam, good. Square root is always plus or minus. So you can check this if you don't believe me. But if you put in positive 20 times positive 20, you'll get 400. What if you put in negative 20 times negative 20?
400.
Still get 400, right? So the VF can be plus 20 or negative 20. Why does that, I don't understand. Why does that work? How can your final velocity be two different numbers? Ashley?
Oh.
I guess,
Oh.
like, two.
Yeah, go ahead, think, talk.
If you have a final velocity for the first part of the trip and the second part of the trip.
So here, you're gonna go upwards, right? So here the VF we would call 20, but over here, you're going downwards. So this VF is negative 20. Okay. So now you can take your VF and you can solve for using 20, and you can solve using negative 20, and you can find the time at both. Okay, so let's do that. I'm gonna just get a new board here. Can you see this board on the video?
Yes.
What formula would you use to do this? We have VF equals 20, and we have VF equals negative 20. And we know VI is, what's VI? 30. And we know A is negative 9.8. And we're looking for T. What's the easiest formula to use? Go ahead and just use the first one, right? We want to solve for T. So VF minus VI over A will equal T. So for this one, we're going to go 20 minus 30 over negative 9.8. I'll round it to 10. So this is going to be around 1 second, I believe. Right? Negative 10 over negative 10. No, positive, yeah, positive 1. What's the answer for the first bit? For the first time?
Yeah,
1? 1 second. And then over here you do the same formula, but now I'm putting a negative 20 minus 30 over negative 9.8, which in my head I'll round to negative 10. So now we have negative 50 over negative 10, so this is going to be somewhere around 5. 5.1 maybe? So here's time 1 and here's time 2. You can check those if you want to try out the quadratic formula thing. You can do it that way as well. Or you can do it in 2 steps. Find the velocity first and then find the times. It's kind of interesting, how math can show you the real world. It's weird. Sometimes the real world, we make the math to represent the real world, but sometimes the math shows you the real world. So it shows you that it's going to be at this place at 2 different times. Which time is this place? The 1 second or the 5 seconds? Good, so this is going to be T equals 1 second, and over here, this is going to be 5 seconds after the toss. So in between, this thing probably goes quite a ways, right? Because it's going to be up there 4 seconds above 25. Okay, that's it. Yes, Azia? Okay. You solve.